Let's talk about rendering and why your site loads slow. In this first episode, we are going to journey through time and explore the evolution of how web pages are rendered in your browser. It feels like every day there is a new front-end rendering technique, a new framework, a new buzzword promising to revolutionize the web. And let's be honest, it can be quite overwhelming. It's hard to keep up, let alone figure out which of these techniques are actually worth your time and which are just hype. By the end of the series, I promise it will all make sense. Let's start from the very beginning, and I mean the very beginning. First, we have static site generation, the OG of web development from the early 1990s. This method served pre-built HTML files straight to the user, providing a simple and efficient way to display content online. Pages were built ahead of time and delivered as is, making the web fast but static. Back then, speed was crucial. I can almost hear the sound of a modem working hard to get my page. This simplicity meant fewer server resources were needed, leading to quicker load times and reduced costs. Simpler times, but effective for its era. We moved to server-side rendering from the mid-1990s. SSR dynamically generates HTML on the server for each request. Think of PHP as the chef, cooking up fresh HTML spaghetti and earning that first Lambo money on weekends. PHP became the backbone of many websites, enabling dynamic content generation. PHP's simplicity and effectiveness made it popular choice among developers, allowing them to embed scripts within HTML to fetch and display data from databases. This capability turned the web into a dynamic and interactive space, as opposed to the static pages of the past. The mid-90s were all about dynamic, server-generated content, allowing for more personalized and up-to-date pages. Late 90s to early 2000s saw the rise of client-side rendering, with JavaScript and Ajax. CSR allowed browsers to fetch data asynchronously and render content dynamically. It was like giving browsers a brain, making web pages more interactive than ever. Users could enjoy faster interactions, like dynamic form submissions and content updates, all without the dreaded full-page reload. December 1999 brought us ECMAScript 3, where JavaScript grew up. This version introduced essential features, laying the foundation for modern JavaScript. The stock market crashed. Because of the dot-com bubble crash, progress in web development was somewhat stalled for the next decade. Fast forward to August 26 and jQuery was released. This game changer made JavaScript easier to use with its write less, do more philosophy. It simplified HTML document traversal, event handling, and animations, becoming every developer's best friend. It also helped standardize cross-browser compatibility issues. December 29 saw the release of ECMAScript 5. This version leveled up JavaScript with strict mode, new object methods, and enhanced array functions. ES5 made JavaScript more robust and easier to maintain. The stock market crashed. ES5's improvements were crucial in making JavaScript more reliable and feature-rich, which laid the groundwork for the modern JavaScript frameworks we use today. 2010 was the year SPAs emerged, transforming web development by loading content dynamically, without full-page reloads. SPAs made web apps feel more like native apps, with faster navigation and seamless interactions. SPAs significantly improved developer experience by simplifying the development process. They allowed developers to build applications in a modular fashion, reducing the complexity of managing state and routing. This modular architecture facilitated a more intuitive workflow, as developers could focus on building interactive elements without worrying about server-side routing. With the advent of SPAs, we finally had full-fledged frameworks that provided developers with rich features like built-in testing tools, state management, and development environment. These frameworks offered comprehensive solutions that integrated various aspects of application development, from debugging and testing to build automation and performance optimization. Additionally, SPAs made it easier to create rich, interactive user interfaces that could update in real time without requiring a full-page refresh. This improved both the performance and user experience of web applications, making them more responsive and engaging. AngularJS launched in 2010, revolutionized web development with two-way data binding and MVC architecture. It made building SPAs easier and more efficient, enhancing HTML with powerful directives and creating dynamic, responsive web applications. AngularJS enabled developers to create more complex applications with less effort, pushing the boundaries of what could be achieved in the browser. Its declarative approach to UI development simplified the process, allowing developers to focus more on the logic and less on the boilerplate code. Between 2011 and 2016, the web development saw an explosion of JavaScript frameworks. Ember focused on convention over configuration, promoting strong opinions on how applications should be built. React revolutionized UI development with its virtual DOM, making it easier to manage and update complex user interfaces. Vue offered a flexible, approachable alternative, balancing simplicity and performance. Svelte introduced a radical approach by compiling components at build time, resulting in highly optimized framework-free code. Solid emphasized fine-grained reactivity, providing efficient and flexible updates to the UI. While these frameworks provided developers with powerful tools to build complex and interactive web applications, their growth also led to big bundle sizes and slow loading times. The need to include entire frameworks in the client-side codebase increased the amount of JavaScript that had to be downloaded and parsed by the browser, impacting performance. This trade-off highlighted the importance of performance optimization techniques to balance rich functionality with fast, responsive user experience. That's why developers started going back to the server, seeking ways to optimize performance and improve load times by offloading more work to the server-side processes. Circa 2016, hydration became popular. This technique converts static server-rendered HTML into dynamic pages on the client side. It bridges the gap between server-side rendering and client-side interactivity, delivering a fast initial load with dynamic capabilities. Hydration enhances user experience by combining the best of both worlds, making static HTML come alive with the power of JavaScript. This approach allowed developers to serve fast-loading static content initially and then seamlessly transition to a fully interactive application. Around 2016, the JAMstack architecture began to gain popularity, revolutionizing how we think about static sites. JAMstack stands for JavaScript, APIs, and Markup, and it combines these elements to deliver dynamic capabilities with the performance and security of static sites. The key to JAMstack is its API-first architecture, where the backend services are decoupled from the frontend. This means you can pull in data from various APIs to create rich interactive experiences without relying on a monolithic backend. The static markup is pre-generated, ensuring fast load times and a smooth user experience. The 2020s have seen significant advancements in web development and performance optimizations, with Vercel and edge computing leading the charge. Vercel leverages edge computing to deliver content closer to the user, reducing latency and improving load times. Edge computing processes data and delivers content at locations closer to the user, ensuring faster, more responsive web experiences. Vercel introduced incremental static regeneration, which updates static content dynamically, combining the speed of static sites with the flexibility of dynamic updates. December 2020 introduced React Server Components. RSC brings server-side rendering to React, reducing the client load and improving performance. By splitting the work between the server and the client, RSC enhances SEO and provides a seamless user experience. In 2021, Astro introduced the Islands architecture. This static site generator delivers minimal JavaScript for optimal performance with interactive components where needed. Astro offers a lightweight, fast approach to modern web development, combining the best parts of static sites with dynamic interactivity. It's all about doing more with less, optimizing both performance and developer experience. Astro's approach reduces the amount of JavaScript shipped to the client, leading to faster load times and improved performance. Circa 2022, qwik brought us Resumability, allowing applications to load quickly with minimal JavaScript. Resumability ensures that the applications are interactive almost instantly, even on slower networks, by prioritizing essential functionality and deferring non-critical paths. 2021 also saw the introduction of htmx, a tool that enhances HTML with powerful interactivity without relying heavily on JavaScript. htmx allows developers to add Ajax, CSS transitions, WebSockets, and server-sent events directly through HTML attributes, simplifying the process of creating dynamic web applications. htmx embraces a declarative syntax, making it easy to enhance web pages with minimal JavaScript. This approach reduces the complexity of client-server interactions, allowing developers to focus more on HTML and server-side logic. htmx improves performance and simplifies development, offering a refreshing return to the basics of web development. And there you have it, the fascinating evolution of web rendering techniques. From the humble beginnings of static HTML to the advanced frameworks of today, each step has brought new possibilities and improvements. We've seen how each technique has shaped the web, making it more dynamic, interactive, and efficient. Whether you're building a simple website or a complex web app, understanding these techniques will help you make the best choice for your project. The journey doesn't stop here though. In the next episode, we'll dive into the interplay between developer experience and user experience. We'll examine key metrics like core web vitals to understand how they impact performance and usability. Thanks for watching, and as always, happy coding!